we are going to the next speaker, with the next talk from Robbe Sneyders. Maybe you can already turn on your camera. Yeah, there you are.
Yes.
Robbe is head of delivery at a machine learning consultancy firm and also a machine learning engineer. Your company is headquartered in Belgium, and well, you're going to tell actually how it is like working at a machine learning consultancy firm. Can you maybe tell us in like 1 minute a bit more about your background and then start well, your presentation or your talk?
Right, perfect. Thanks, Robert. So yeah, I'll already quickly share my screen since I have an introduction slide there as well, which is a bit easier. So I'm the head of delivery at ML6. And before this, I worked as a machine learning engineer and as a team lead. So I have more than 3 years of experience as a machine learning engineer as well. And now I'm responsible for the delivery of all of our projects and for the coaching of our full technical team. So everyone who works on a project, I work together with them. And like you said, today, indeed, I will be talking about what is it like to work at ML6 at a machine learning consultancy firm. So maybe a quick overview. I'll quickly give some info on ML6 as some context. We call ourselves a machine learning services company. So I'll talk about what that means. Then also about why we have machine learning engineers and not some other roles. And then finally, we'll look at our internal structure, which is composed of squads and chapters. And then finally, I hope to keep some time for the Q&A. So if you have any questions during the talk, make sure to submit them and then we can discuss them afterwards. So ML6 is, like I said, a machine learning services company. And our vision is to accelerate intelligence, both internally for our people and externally for our clients. So how do we do this? We do this with more than 70 machine learning experts and 5 offices. So our headquarters is in Belgium, but we also have offices in the Netherlands, UK, and Germany. And especially in the Netherlands, we are growing quite fast. Also in Belgium, we've been the largest and fastest growing AI company for the past 3 years, as declared by Deloitte's Fast 50. Also important to know is that we are a premier partner for Google Cloud with a machine learning specialization. So what this means is that we build our solutions on Google Cloud. And whenever a client of Google needs a machine learning solution, then Google will involve us and check if we can help that client. 15% of our workforce is also dedicated to applied research. And this is not 15% of the people, but 15% of the time of everyone, which is a very big distinction, which we will talk about more later. And we contribute to open source. So we contribute to some tools. A bit special is that we do not have a focus on one machine learning domain, but a machine learning project. So as long as there's an interesting problem for us to solve, which requires a real custom solution, that will do it. But it's mainly in these 4 domains, which is NLP, computer vision, time series, and recommender systems, which are mostly about ranking and matching. So if you look at our clients, we're in production at more than 100 customers across different industries. So you can see some of their logos here. And we're active in life sciences and healthcare, in the public sector, in financial services, in communication, and much more. So that was a short introduction. So what does it mean when I say we're a machine learning services company? To explain this, let's first look at the other type of company, which is a product company. So a product company is a company that builds its own product or product suite and sells this to its clients. So every team in the company works on this product or on this suite of products. And one very nice example of a product company in machine learning is, for instance, Google. Compare this to a service company. we don't build our own product, but we sell our services to our clients to help them build their products. So this has some advantages. You have a lot of different use cases and a lot of different companies and sectors, like I showed before. And since we have a lot of different projects, there's a lot of opportunity to take ownership and responsibility and really grow very rapidly. Now, of course, there's also a downside. Since there's a lot of different projects, a lot of service companies have a problem that their teams get disconnected. But that's why at ML6 we focus a lot on the central core that keeps us together as well. So to give some examples, we do not work at a client like some other consultancy firms. We always work from our own offices, or currently, of course, mostly from home. But this is very important to us because it enables cross-project knowledge sharing. Since we're always together at the same office, you see other people, you talk to them, you learn from them. And it's just a very good way to keep a very wide knowledge. We also spend a lot of time on our own applied research and internal tooling that can be reused across projects. And then finally, we have a big focus on people support. It's very important to us that our people work on projects that they like, that they are challenged, that they can grow. Since we're a service company, our people are really the most important part of the company. But before looking more at the center, let's have a quick look at our projects. So there are 3 types of projects that we do. The first one is a proof of concept. So this is the first project we do at a new client. And the goal here is to assess the technical feasibility of a solution and to demonstrate that we can add value with intelligent technology for a problem that the client has. So this is mostly, a bit more researchy. It's trying to check what can be done with their data, which kind of models can we apply, and what are the results. But these projects are quite small as well. The goal is to, as quickly as possible, prove that we can help them solve a problem. So the next step then is, once we've proven this, is an MVP, where we try to put this model in an application, so really an end-to-end solution. And the goal here is to assess if the model we build can also perform in a real-life situation. So on real-life data, which is sometimes changing compared to a fixed data set. Sometimes we do a proof of concept on individual frames, while we actually need to work on video in the end product. So that is a step we take here. And then the final part is a project putting machine learning into production. So this is the goal where we always want to get. Here we set up a solution that can be fully integrated with the client systems. It is completely automated. It retrains the model automatically, and it is fully scalable. If there's a lot more traffic coming to our application, then it should be able to handle that. And the most important part here is that this is the place where we create real value. So we provide very useful insights in the proof of concept and the MVP, but only when we really put machine learning into production at a client, it will start generating value for them and their users or their own clients. So it's very clear that this is an iterative approach, which is very important to us. So we will not design the end solution from the start and then start building separate components. What we do is we start small, we build something that we get insights from, and then we check how can we improve this, how can we make it bigger, and that's how we keep going until we have a real end-to-end solution that solves their problem. Now, if we look at our teams working on these projects, these are the 4 main roles that we have. So we have machine learning engineers, software engineers, data engineers, and project managers. But we do not have data scientists, data analysts, business analysts, or any other role which is related to data science. And this is with the reason. So why do we only have machine learning engineers? I think this quote from Google summarizes it very well. So the real challenge is not building the machine learning model. The challenge is building an integrated machine learning system and to continuously operate it in production. So this is, or ties back to what I said earlier, that we only start generating value when we put something in production. And this is really the end goal for everything. So we need the skills to get there. Also, if you look at one of these real-world machine learning systems, you will see that only a very small fraction is actual machine learning code. So developing the model is only a small part of the tasks. There is a lot of work with data. You need to serve your models. You need to have analysis of your results to keep up with data shift and so on. But the nice thing is, this is still all very much related to machine learning. So you might not be coding a TensorFlow model all the time, but even the serving is machine learning specific. It has additional challenges that you don't have with traditional software. The same for your model analysis. How do you know when a model is good enough to deploy or not? It's often not easy to define good metrics because the real world data is very fuzzy. It can be very subjective. So the machine learning challenges here are just a lot wider than only developing the model. Also, if we look at these different stages, you will see that we need a lot of different skills. So in a proof of concept, it's mostly about business analysis, data exploration, and trying to fit your first models on the data, evaluate how well they work. In the MVP, it's more about the data engineering, about serving your models, setting up APIs, really do the software engineering. And then when going into production, additional skills are needed about systems design, automation, scaling, and monitoring. So really that systems design is an important one. You need to be able to think about machine learning on a systems level. And a short example that shows this is one of our use cases, which I can showcase. So the goal here for the client was to auto-produce football game video footage. So the only thing we received was this wide-angled video footage from a soccer match, and they wanted to make something that was fun to watch at. Like I can tell you, if you have to watch 90 minutes of this, it's not very interesting. But let's see what happens when we turn on our solution. You can see that the camera starts following the ball and the action on the field. How we do this is via object detection. So we detect the different players from different teams and the ball. And you can see that we also can display this on a minimap and gather statistics. So this is not an easy task. Just a very high-level summarization is that we have event detection going on both on sound and video. So we detect goals, fouls, the start of a game. For the detection of the players and the ball, we do object detection and then team classification. You also need to know which team is which, to know who scored, who made a foul, and so on. You can see that the camera is very wide angled, and this differs between different football fields. They're not always set up exactly the same. So we also need a model to de-warp the field into a normal 2D plane. And then you need to connect the output of all these models together to generate statistics, the auto production, and the minimap, and so on. So this just shows that you need to be able to think about machine learning on a very high level as well to build this kind of solution. So to summarize, what a machine learning engineer, which skills they need is, first of all, machine learning related. It's about data, about models. It's software development, and it's ops. It's about deployment, about systems. So we really need people that can combine all these skills. And if that didn't sound like enough yet, we are also a services company. So everyone works together with clients directly. So yeah, we also need people who have communication skills, business understanding, problem solving skills, and who can make trade-offs. If there's a limited scope, time-wise or budget-wise from the client, then we need to be able to take decisions. What will we build that will solve this problem as quickly as possible within the budget? Where can we take shortcuts and still get the best results that we can?
Thank you very much, Robbe. Sorry, are you ready? I thought you were ready. Excuse me.
Sorry. Not yet. I have a very short additional part. So, of course, not everyone can do everything. So we are mostly looking for T-shaped profiles, people that are both generalist and have deep expertise at the same time. So I'll quickly go over this so you can see people at ML6 have one expertise but know a lot about all the other machine learning stuff as well. So we have computer vision experts in productionizing, but they always know general things about the other domains as well. So just quickly about how we support this is with our internal structures. So we work in squads and chapters. So everyone who delivers a project is part of a squad, which is a self-steering multidisciplinary team. So it contains all the roles I showed before, and they deliver their own projects end to end. They're responsible for their own planning and delivery, and they're coached by a squad lead. But so this way we group the different small projects from different small teams for the different projects, and we add them to a bit of a bigger team from 8 to 12 people. We also have the chapters who are cross-squad, and these are expert teams focused on one domain. So for instance, natural language processing, and they do applied research, they build internal tooling to use on our projects, they generate blog posts and videos, and they support our project delivery. If we need an NLP expert on a project and the people on the project are not comfortable enough with the domain, then they can reach out to the chapter for support. And then finally, they share their knowledge 4 times a year in a chapter conference, which is internal. And here they give an overview of what they did, the research they did, the state of the art in their domain, what we did on projects in their domain. And while you cannot stay up to date about all the machine learning domains yourself, this way we can stay up to date about them together. All right, that was it, Robert.
Yes, thank you, Robbe. Thank you very much for your interesting talk. The last few minutes, the connection was a bit noisy. Well, here it was. I'm not sure how it was for the other attendees, but we could hear you. I could hear anything you said, so that's good. So I do have a question for you. Maybe it's something with your speaker or microphone. I'm not sure. But Bert is asking you, what is the most important skill if a junior data engineer applies for a job at ML6?
That's a very good question, and I think it is problem solving. So we want people that can find ways to solve problems themselves, that can work independently while we provide them the support that they need to really achieve their best results. But we do not have strong requirements on experience. We have people coming in that have never coded, for instance, in TensorFlow, which is the tool we use mostly to develop our models. As long as we know that they can solve problems and they have a very strong scientific background, that's the most important part for us.
Okay, thank you. I have another question. Do people have like enough machine learning skills when they graduate from like a data science university program?
It has improved a lot. So when I started at ML6 almost 4 years ago, there almost were no real courses for machine learning and artificial intelligence. So it has matured a lot. So now we see people with a lot more experience coming in. But I still think that you will learn the most once you start working. So you most of all need to have a very strong basis in mathematics and science. So you can handle any new problem that comes up, so you can handle any new techniques that are developed. I think that's still where you learn the most.
Okay. Thank you very much. Thank you again, Robbe.